The Gamble, Iron Curtain, Ghost Roads, Dragon's Breath, Bear Wall, Shorad Fury, Island Fire, Volt Charge.
It arrived in Iraq 63 hours after deployment orders were signed. No other armored vehicle in the American arsenal could claim that speed. The Stryker wasn't built for the heaviest punch or the thickest armor. It was built to get there first. From the streets of Mosul to the mountains of Afghanistan, from Pacific jungle rotations to live-fire exercises on the European steppe, this 8-wheeled infantry carrier has been the first boots-on-ground platform for over 2 decades. What follows are the missions that forged its reputation, starting with a gamble that nearly ended its program before it began. The Stryker's design philosophy centers on a radical compromise. It sacrifices heavy armor protection for strategic mobility. Its 8-wheel independent suspension allows speeds over 60 miles per hour on paved roads. It also maintains off-road capability that tracked vehicles struggle to match. The flat-bottomed hull and modular armor system represent a deliberate bet. Speed and deployability matter more than raw survivability. In 2003, the Pentagon faced a problem. The 3rd Infantry Division had punched through to Baghdad in 3 weeks. But holding what they'd taken required a different kind of force. Tanks couldn't patrol narrow streets without crushing infrastructure. Humvees offered no protection against the growing IED threat. The answer was already rolling off General Dynamics assembly lines in Ontario, Canada. The 1st Brigade, 25th Infantry Division received orders to deploy with a full Stryker brigade. No one had ever tested this concept in combat. Skeptics called the vehicle a death trap. Too light for real war, they said. The aluminum hull would melt under RPG fire. Congress demanded answers. The Army said, "Trust us." In October 2003, the Stryker Brigade combat team touched down in Kuwait. Within days, they pushed north into Mosul. The first patrols rolled through streets that had swallowed Humvee convoys whole. Soldiers could dismount from the rear ramp in seconds. They cleared buildings and remounted before the enemy repositioned. The vehicle's quiet engine let it approach intersections without announcing its presence 3 blocks away. In the first 90 days, the brigade conducted over 4,000 patrols with 0 Stryker losses to enemy fire. The gamble paid off. But the real test hadn't started yet. The IED war arrived with industrial precision. By mid-2004, insurgents in Iraq had moved beyond simple roadside bombs. They were stacking anti-tank mines, daisy-chaining artillery shells, and burying copper-lined explosively formed penetrators. These were designed to punch through anything short of an Abrams. The Stryker's flat bottom was its greatest vulnerability. Explosively formed penetrators work by detonating a shaped charge behind a concave copper disc. The explosion transforms the disc into a superplastic slug. It travels at roughly 2 kilometers per second. This slug can penetrate several inches of rolled homogeneous armor equivalent. That far exceeds the Stryker's base hull protection rating. Engineers responded in weeks, not years. The first fix was bolt-on slat armor, the steel cage surrounding the vehicle that detonated RPG warheads before they reached the hull. It added weight but saved lives. Then came the V-shaped hull kits, redirecting blast energy away from the crew compartment. Electronic countermeasure jammers went on next. They blocked radio-triggered detonators. By 2006, a Stryker rolling through Diyala province looked nothing like the clean vehicle that left the factory. It was a rolling fortress of improvised engineering. Soldiers welded scrap metal to weak points. Units shared modification blueprints over classified networks. The vehicle adapted faster than the threat. When a new EFP variant appeared in southern Baghdad, the counter-kit arrived at forward operating bases within 6 weeks. This cycle of attack and adaptation defined the Stryker's character. It wasn't invincible. It was fixable. And it kept rolling when other platforms would have been pulled from service. That adaptability would matter even more in a theater where roads didn't exist. Afghanistan presented a fundamentally different problem. No paved highways through Kandahar province. No flat desert to sprint across. Just grape rows, irrigation ditches, and dirt paths that turned to mud paste every spring. Critics said the Stryker couldn't operate here. They said its wheels would sink, its width wouldn't fit the trails, and its weight would collapse the ancient bridges. In 2009, the 5th Stryker Brigade deployed to southern Afghanistan to prove them wrong. They pushed vehicles into terrain that the manufacturer never designed for. Soldiers built improvised ramps to cross canals. Engineers reinforced bridges overnight with steel beams flown in by Chinook helicopters. The brigade developed new tactics. They used Strykers as mobile command posts while infantry squads moved on foot through the green zone. Vehicles provided Overwatch with their remote weapon stations. They fired .50 caliber rounds with precision from 1,000 meters. The crew remained fully protected inside. One engagement near Arkandab district lasted 11 hours. 3 strikers held a position on a ridgeline while 2 platoons cleared a Taliban strongpoint below. The vehicle's rotated ammunition resupply runs through a single-lane trail. That trail would have been impassable for tracked armor. By the end of the deployment, the brigade had operated Strykers in conditions that should have been impossible. Wheel failures increased. Maintenance hours doubled. But the mission got done. And the next evolution was already waiting. The Stryker M1128 mobile gun system mounts a 105mm cannon on the standard Stryker chassis. Key features include the auto-loading ammunition system capable of storing 18 rounds, the low-profile turret with advanced fire control computer, the laser rangefinder integrated with thermal imaging sights, and the ability to fire while moving at speeds up to 25 miles per hour. The mobile gun system variant changed everything. Suddenly, a Stryker brigade had its own direct fire support without calling for tanks. In 2007, an M1128 crew in Baku engaged an insurgent position fortified inside a concrete building. The 105-round punched through the wall on the first shot. The building collapsed inward. No friendly casualties. No collateral damage to adjacent structures. Conventional doctrine would have required an airstrike or a tank platoon. The MGS did it alone. But the platform had limitations. The autoloader jammed in extreme dust conditions. The gun's recoil stressed the lighter Stryker chassis beyond design tolerances. Crews developed workarounds. They pre-staged rounds, cleaned the loading mechanism every 4 hours, and limited sustained fire to 3 rounds per minute. This protected the hull welds. In Sadr City during 2008, MGS crews fired over 200 rounds in a single week of urban operations. They suppressed sniper positions, breached compound walls for infantry entry, and destroyed vehicle-borne IED threats. Engagement distances exceeded 1,500 meters. The platform earned respect the hard way. It proved that a wheeled vehicle could deliver firepower previously reserved for 60-ton tracked monsters. The Stryker was becoming something the Army hadn't originally planned. It was becoming a weapon system, not just a transport. That evolution accelerated when the enemy stopped being insurgents. In 2015, Russia annexed Crimea and destabilized eastern Ukraine. NATO's eastern flank suddenly felt exposed. The Stryker's original selling point, rapid strategic deployment, became its most critical capability overnight. Operation Atlantic Resolve put Stryker brigades on a continuous rotation through Eastern Europe. The 2nd Cavalry Regiment, based in Vilseck, Germany, became the tip of NATO's spear. NATO's enhanced forward presence strategy positions multinational battle groups in Estonia, Latvia, Lithuania, and Poland. The concept relies on rapid reinforcement rather than permanent heavy armor positioning. Stryker brigades provide the fastest deployable armored response capability in the American inventory. They can self-deploy over 1,000 kilometers on European highway networks within 48 hours. In 2016, the regiment conducted Dragoon Ride, a 1,700-kilometer road march from Estonia to Germany. Strykers rolled through 6 countries in 4 days. The message to Moscow was deliberate. These vehicles could be anywhere on the continent in 2 days. No rail loading. No port offloading. Just highways and fuel stops. The exercise revealed real logistics challenges. Tire wear on European roads exceeded projections. Bridge weight limits in rural Poland forced route changes. Fuel consumption at highway speeds drained tanks faster than the supply chain anticipated. But the strategic effect was undeniable. The Stryker became NATO's visible deterrent. A constant presence on roads that Russian planners had to factor into every scenario. By 2018, rotations were continuous. Stryker crews trained alongside Estonian, Latvian, Lithuanian, and Polish forces. Combined arms exercises that would have been unthinkable a decade earlier. The vehicle designed for counterinsurgency was now rehearsing for great power war. Then it needed a serious upgrade to survive that fight. The Stryker IM-SHORAD initial maneuver short-range air defense represents a radical transformation of the platform. It integrates a Moog reconfigurable turret carrying 4 Stinger missiles, 2 Hellfire longbow missiles, a 30mm M230 chain gun, and an electronic warfare suite. The suite detects and jams small drones. This configuration gives Stryker brigades organic air defense capability for the first time. For 20 years, the U.S. Army had neglected short-range air defense. The assumption was simple. American air superiority made ground-based air defense unnecessary. Then drones changed everything. In 2020, Azerbaijan used Turkish-made Bayraktar drones to devastate Armenian armored columns in Nagorno-Karabakh. The footage went viral. Pentagon leadership watched tanks explode from weapons costing a fraction of their value. The Stryker-based IM-SHORAD system went from development program to urgent operational need. The 5th Battalion, 4th Air Defense Artillery Regiment received the first systems in 2021. By 2022, they were deployed to Europe with operational Stinger and Hellfire capability. In training exercises, crews demonstrated the ability to detect, track, and engage drone targets within 15 seconds. The 30mm cannon provided a cost-effective solution for smaller drones, each round costing dollars instead of the hundreds of thousands a missile would require. The system transformed the Stryker from a vehicle that needed air defense protection into one that provided it. Brigade commanders suddenly had organic counter-drone capability rolling alongside their infantry columns. The gap that Nagorno-Karabakh exposed was being filled, but the Pacific theater demanded something even more radical. The Indo-Pacific pivot required the Stryker to do something it had never done: fight from islands. Traditional Stryker operations assumed continental road networks. Pacific operations meant short airstrips, narrow jungle roads, and engagements measured in nautical miles. Island chain defense strategy envisions distributed forces positioned across archipelagic terrain in the western Pacific. Small units equipped with long-range precision fires would operate from dispersed positions on islands. They create overlapping engagement zones that deny an adversary naval and air superiority. No concentrated forces that present easy targets. In 2023, Stryker units participated in exercises across the Philippines. They conducted beach landings and jungle operations. Vehicles were loaded onto C-17 transport aircraft and delivered to austere airfields. Crews practiced rapid displacement. They fired from one position, then moved within minutes before counter-battery radar could fix their location. The Army's plan was ambitious: mount long-range missile launchers on Stryker chassis, push them to forward islands, create a web of mobile anti-ship capability that could threaten naval forces, ranges exceeding 100 nautical miles. The concept challenged everything the Stryker was designed for. It was no longer an infantry carrier. It was becoming a mobile missile battery. Exercises at Balikatan in the Philippines tested the logistics. How do you resupply a Stryker unit on a remote island? How do you evacuate casualties when the nearest hospital is 400 miles away by sea? How do you maintain an 8-wheeled vehicle on volcanic rock roads? The answers weren't perfect, but they were being worked out in real time. The vehicle's fundamental advantage, fitting inside a C-17, made it the only armored platform that could get to these islands at all. The most radical Stryker mission hasn't been fought yet. It is being tested. In 2024, the Army began evaluating hybrid electric Stryker prototypes. The concept is transformative. Hybrid electric drive systems replace the conventional diesel-only powertrain with an integrated diesel-electric system. The electric motors can propel the vehicle in near-silent mode at reduced speeds. This eliminates the acoustic signature that alerts enemies to approaching vehicles. The stored electrical power also enables directed energy weapons, high-powered sensors, and electronic warfare systems. These would overwhelm a conventional vehicle's electrical generation capacity. The Yakima Training Center in Washington State, prototype Strykers demonstrated silent approach capabilities. Vehicles operating in electric-only mode reduced their acoustic signature by over 90%. Thermal signature dropped similarly. They became nearly invisible to infrared detection at distances beyond 500 meters. The implications extend beyond stealth. A hybrid electric Stryker can generate enough power to run a 50-kilowatt directed energy laser. That's enough to shoot down incoming drones, mortar rounds, and potentially even cruise missiles. The same power bus can feed electronic warfare systems. These systems jam enemy communications across multiple frequency bands simultaneously. Fuel consumption in hybrid mode drops by roughly 30%. This extends operational range without additional logistics burden. The Army's target is full fleet conversion by the early 2030s. When that happens, the Stryker won't just be faster and quieter. It will be a mobile power plant. It will support weapon systems that today require dedicated generator trucks. The vehicle that started as a compromise between speed and protection is evolving into something its designers never imagined. From Mosul to the Baltics, from Afghan mountain passes to Pacific island chains, the Stryker has been wherever the mission demanded. And it gotten there before anything else in the inventory. It was called too light, too thin, too compromised. It answered with 20 years of continuous combat deployment. If this is your first time on this channel, consider subscribing. We cover the missions, the machines, and the moments that define modern warfare. Hit the notification bell so you don't miss the next one.